2 weeks ago, scientists went back to a set of photographs taken 11 years ago and found something in them that nobody had ever seen. Not because it was hidden, because nobody had thought to look for it. The photographs were taken by a spacecraft called New Horizons on July 14, 2015, during a flyby of Pluto that lasted a few hours. In those few hours, the spacecraft captured the most detailed images of Pluto's surface that had ever existed, or that may ever exist again. Scientists have been studying those images for over a decade. They have published hundreds of papers based on what they found. They have mapped glaciers, mountains, volcanoes, and atmospheric layers that nobody expected to see on a world that small and that cold. And then, in July of 2026, a team of researchers looked at the same images one more time, from a slightly different angle, and found 6 massive landslides sitting in plain sight on the walls of 3 impact craters. Landslides that had been there in the data since the day the photographs were taken. Landslides that cover areas twice the size of Manhattan, on a world where you would weigh about as much as a house cat. But here is what turns this from a surprising discovery into something much bigger. The spacecraft that took those photographs did not stop at Pluto. It kept going. It flew on to visit the most distant object any spacecraft has ever reached, a frozen relic from the birth of the solar system that nobody had even discovered when New Horizons launched. And then it kept going further. And while it was out there, sleeping in the darkness of the Kuiper Belt, the most powerful telescope ever built turned its eye toward Pluto and found something on its surface that New Horizons never could have detected, a chemical signal that does not match any known molecule in any database on Earth. And then, 3 weeks ago, the spacecraft woke up, 5.9 billion miles from home, still functioning, still collecting data, still not finished. Stay with me, because by the time this is over, a spacecraft that was supposed to be a footnote is going to change how you think about what one mission can do. I'm Graham Prescott, and this is your channel. Subscribe now if you want more stories like this, because we are just getting started. It was supposed to be a simple flyby. Get in, take pictures, get out. New Horizons launched from Cape Canaveral on January 19, 2006, on top of an Atlas V rocket, moving faster than any spacecraft ever sent from Earth, at roughly 36,000 miles per hour. It crossed the orbit of the Moon in just 9 hours. Most Apollo missions took 3 days to cover the same distance. 13 months after launch, it swung past Jupiter, using the giant planet's gravity as a slingshot to add another 9,000 miles per hour to its speed and shave 3 years off the trip to Pluto. During that Jupiter flyby, it captured new images of the planet's storms and its volcanic moon Io, testing its instruments on familiar targets before the long silence ahead. And then came the silence. Year after year of crossing empty space, with the spacecraft cycling in and out of hibernation to conserve power and reduce wear on its systems. Mission controllers at the Johns Hopkins Applied Physics Laboratory would wake it periodically, check its health, confirm its trajectory, and send it back to sleep. 9.5 years of that. 9.5 years of a machine the size of a grand piano drifting through the void at 10 miles per second toward a target smaller than Earth's moon that no spacecraft had ever visited. On July 14, 2015, New Horizons arrived. It crossed above Pluto's surface at a distance of 7,800 miles, moving so fast that the entire close encounter lasted only a few hours. Every instrument on board was running at maximum, capturing as much data as possible before the window closed. There would be no second pass, no orbit, no return. Whatever it saw in those hours would be everything. And what it saw rewrote the textbook on what a small, cold, distant world can be. Pluto was not a dead ball of ice. It was alive. The heart-shaped basin called Sputnik Planitia stretched 1,000 miles across, filled with glaciers of nitrogen ice bigger than Texas and Oklahoma combined. The surface of those glaciers was not flat. It was divided into polygon-shaped cells, some of them 20 miles across, formed by convection, the same process that drives weather on Earth. Warm nitrogen ice rising from below, spreading across the surface, cooling, and sinking back down. Slowly, endlessly, the glacier was churning, like a pot of water on a stove set to the lowest possible heat. This convection was erasing impact craters as they formed, which meant the surface of Sputnik Planitia was geologically young, perhaps only a few million years old, on a world that is 4.5 billion years old, on Pluto, a world with a surface temperature of minus 230 degrees Celsius. A world that was supposed to be geologically dead. Bordering the glacier were mountain ranges made of water ice, some standing over 11,000 feet tall. Water ice, frozen so hard at those temperatures that it behaves like stone, forming ridges and peaks comparable in scale to parts of the Rocky Mountains. Inside the glacier basin, fragments of that water ice had broken off from the highlands and were floating on the denser nitrogen ice like icebergs on an Arctic ocean. Carried along by the slow convective currents, drifting across a frozen sea under a sky that receives only a fraction of 1% of the sunlight that falls on Earth. Pluto had icebergs. Above the surface, a blue layered atmosphere stretched more than 200 miles into the sky, far more extensive and more complex than anyone had predicted. Organic haze particles were raining down from the upper atmosphere, coating the surface with a reddish-brown residue that gave Pluto its distinctive color. And the atmosphere itself was escaping into space at a rate that surprised scientists, interacting with the solar wind in ways that created a tail of ionized gas streaming behind Pluto as it orbited the sun, like a comet. But the most dramatic discovery came south of the glacier basin, where New Horizons found two enormous mountains with large depressions at their summits that looked, from every angle, exactly like volcanoes. Right Mons, roughly 100 miles wide and 13,000 feet high, with a summit crater 35 miles across. Its flanks were covered in a distinctive hummocky texture, and the rim of its summit showed concentric fractures radiating outward. Picard Mons was even taller, reaching nearly 18,000 feet, making it comparable in height to some of Earth's largest volcanic peaks. In 2022, a study published in Nature Communications confirmed what the images had suggested. These were cryovolcanoes, ice volcanoes that had erupted with a slurry of water ice, nitrogen, ammonia, and methane, extruding enormous amounts of material onto Pluto's surface and resurfacing an entire region of the hemisphere that New Horizons observed. Kelsey Singer, the deputy project scientist from the Southwest Research Institute, described them as features unique to Pluto, unlike anything seen elsewhere in the outer solar system. The terrain around the volcanoes showed very few impact craters, which meant the surfaces were geologically young. For cryovolcanoes that size to have erupted that recently, Pluto must have retained far more internal heat than anyone thought possible for a world that small and that far from the sun. Where that heat comes from is still debated. Radioactive decay in Pluto's rocky core is the leading hypothesis, but the magnitude of the volcanism suggests the heat source may be more substantial than models had predicted. That alone would have been one of the most significant planetary discoveries of the decade. Nitrogen glaciers, water ice mountains, floating icebergs, a complex atmosphere, and now confirmed ice volcanoes on a world that was supposed to be a frozen, inert rock. But it was only the beginning of what those photographs contained. And then, 11 years later, someone looked again. In July 2026, a team of researchers led by Marco Emanuele Discenza published a paper in the journal Icarus describing something that had been sitting in the New Horizons images since 2015 but that nobody had identified until now. 6 massive landslides spread across the inner walls of 3 impact craters near the edge of Sputnik Planitia. The evidence was unmistakable once you knew what to look for. Crescent-shaped scars at the tops of crater walls where material had broken away. Giant displaced blocks of ice tumbled down the slopes below. Long debris deposits spilling out across the crater floors, stretching as far as 14.5 kilometers from their source. One of the landslides, designated LD1, had fallen inside Coughlin Crater. The debris had dropped roughly 2.2 kilometers, nearly 1.4 miles straight down, and then spread outward across the crater floor. Close to the rim, the researchers identified a secondary impact crater that may have been the trigger, a smaller collision that destabilized the steep wall and sent the ice cascading downward. 2 more landslides, LD2 and LD3, were found inside Gickless Crater. 3 more sat inside an unnamed crater nearby. Each one showed the same morphological signatures that geologists use to identify landslides on Earth: the concave source scars, the displaced blocks, the long aprons of debris. The largest debris field covered approximately 130 square kilometers. To put that in perspective, that is roughly twice the area of Manhattan. On Earth, a landslide that size would bury a small city. On Pluto, it happened in silence, in near total darkness, on a world where gravity is barely 6% of what it is here. Now, stop and sit with that for a second. Pluto's gravity is so weak that if you stood on its surface, you would weigh about as much as a house cat weighs on Earth. You could jump 6 meters straight up without effort. Under that feeble pull, the idea that ice and rock could generate enough force to trigger landslides, let alone landslides that send debris cascading 14 kilometers across a crater floor, seems almost absurd. But the evidence is there: the crescent scars, the displaced blocks, the debris aprons. They match the morphology of landslides found on Earth, on Mars, and on the dwarf planet Ceres. The physics is the same. The scale is the same. What is different is the friction. On Pluto, the icy rubble has almost no friction, which means that once a landslide starts, the debris travels much farther relative to the height it fell from than it would on a rockier world. The height-to-run-out ratios are extreme. Pluto's landslides are, according to the researchers, among the most mobile in the entire solar system, a product of low gravity, low temperatures, and icy material that slides almost without resistance once it begins to move. Maria Teresa Brunetti, a physicist who studies landslides at Italy's National Research Council and worked on the study, said that Pluto is probably home to many more. Finding them will require more analysis of the existing data and, ideally, more missions to Pluto. The paper's conclusion stated it directly. These observations provide direct evidence that gravitational slope processes contribute to shaping Pluto's surface and expand our understanding of geomorphological activity on icy bodies in the solar system. Landslides had previously been confirmed on Mars, on Ceres, and even on Pluto's own moon Charon. But on Pluto itself, this was the first time. 11 years. The same photographs, and scientists are still finding things in them that nobody saw before. Think about what that means. If a data set from a few hours of observation on one world is still producing first-ever discoveries after more than a decade, consider the hundreds of other worlds in our solar system that we have barely looked at. Over 200 moons, dwarf planets, and Kuiper Belt objects that have received a fraction of the attention Pluto has gotten. Most of them have never been visited by a spacecraft at all. If Pluto is still surprising us with data we already have, what are those worlds hiding in data we have never collected? But the spacecraft was not done, because after Pluto, New Horizons did something that nobody was certain it would ever get the chance to do. It flew to a second target. For years after the Pluto flyby, scientists conducted a painstaking search using the Hubble Space Telescope to find a Kuiper Belt object that was close enough to New Horizons' trajectory for the spacecraft to reach with its remaining fuel. The Kuiper Belt is vast, stretching from roughly the orbit of Neptune outward for billions of miles, populated by thousands of small, icy objects left over from the formation of the solar system. Finding a reachable target among them was not guaranteed. The objects are tiny and faint, often no more than a few miles across, orbiting in the cold darkness at distances where even Hubble struggled to spot them. But in 2014, after a decade-long search, Hubble found one. A small object, designated 2014 MU69, later officially named Arrokoth, a word meaning sky in the Powhatan language. On January 1, 2019, 3.5 years after leaving Pluto behind, New Horizons flew past Arrokoth at a distance of just 2,200 miles, making it the most distant object ever explored by a spacecraft. 4 billion miles from the Sun, more than 1 billion miles beyond Pluto. And what it found there sent the planetary science community back to the drawing board. Arrokoth was not a rough, battered asteroid covered in impact craters. It was a contact binary, two objects that had gently merged together, forming a shape that looked like a snowman lying on its side. A large, flat lobe about 19.5 kilometers across, connected by a thin neck to a smaller, rounder lobe about 14.2 kilometers across. Total length, 22 miles. The surface was smooth, lightly cratered, and reddish in color. Its shape was the biggest surprise of the encounter. Nothing like it had ever been seen anywhere in the solar system. And the way it formed was even more remarkable. Simulations published in the journal Science showed that Arrokoth was the product of a gentle, low-speed merger in the early solar system. Two small objects that had been gravitationally bound to each other, slowly spiraling together over millions of years until they touched so softly that neither one was significantly damaged by the contact. The collision speed was roughly 2.9 meters per second. That is about the speed of a brisk walk. Two worlds, merging at walking speed, 4.5 billion years ago. And the result was still sitting there in the Kuiper Belt, virtually untouched, when New Horizons arrived. The neck connecting the two lobes was slightly brighter and less red than the rest of the surface, consistent with what you would expect at a contact point where material was compressed. But the overall structure was intact. No fractures, no signs of violent collision. No debris field. Just two ancient objects resting against each other in the darkness, exactly as they had been since before the planets finished forming. Arrokoth is what the solar system looked like before the planets existed. It is a relic from the first chapter of our cosmic neighborhood's history, preserved in the deep freeze of the outer solar system for longer than any geological feature on Earth has survived. Studying it is like reading the first sentence of a story that eventually became everything we know. and New Horizons was the only instrument that has ever been close enough to read it. While New Horizons was out there in the Kuiper Belt, drifting further from the sun with each passing day, something else was watching Pluto. The James Webb Space Telescope, launched on Christmas Day 2021, pointed its infrared instruments at Pluto and found things that New Horizons never could have detected. Webb operates in infrared wavelengths that were not covered by New Horizons' instrument suite, which means it was seeing Pluto's chemistry from an angle that had never been available before. And what it found opened two entirely new mysteries. The first was Pluto's climate. Research published in Nature Astronomy in mid-2025 revealed that Pluto's high-altitude haze is not just a visual feature, it is a thermostat. The haze particles absorb sunlight during the day, convert that energy, and re-emit it as infrared radiation at night. This process cools Pluto's upper atmosphere by roughly 30 degrees Celsius, more than any model had predicted. To put that in everyday terms, imagine discovering that your house has been 30 degrees colder than your thermostat says it should be, and the reason is not your heating system, but a thin layer of dust on your ceiling that nobody thought to check. Tanguy Bertrand, the astronomer at the Paris Observatory who led the study, called it unique in the solar system. There is nothing else like it anywhere we have looked. On every other world, the atmosphere's gas composition drives the climate. On Pluto, the haze drives the climate. A completely different mechanism, operating on a world that most people stopped thinking about the day it lost its planetary status. And those haze particles are chemically similar to particles that scientists believe blanketed Earth's atmosphere billions of years ago, when our planet was young and the first building blocks of life were forming. On ancient Earth, a similar organic haze may have shielded fragile molecules from ultraviolet radiation, giving early chemistry a gentler environment in which to become biology. Pluto may be running a live demonstration of a process that helped make Earth habitable. The research team said it directly. By studying Pluto's haze and chemistry, we might get new insights into the conditions that made early Earth habitable. That sentence was buried in a press release about a world most people think of as a frozen rock, and almost nobody noticed. The second mystery was stranger. In June 2026, researchers reported that Webb had detected a spectral absorption signal at 5.1 micrometers on Pluto's surface, a clear, unmistakable dip in the infrared spectrum produced by something absorbing light at that specific wavelength. They cross-referenced it against every known molecular signature in published planetary spectra: ethane, ethylene, acetylene, propane, benzene, hydrogen cyanide, dozens of compounds found across the solar system. None of them matched. Whatever is on Pluto's surface absorbing light at that wavelength has not been identified anywhere, on any moon, any asteroid, or any exoplanet Webb has ever studied. And then they checked Titan, Saturn's largest moon. The same signal was there, same wavelength, same unexplained absorption, 5.11 micrometers. Two completely different worlds, separated by hundreds of millions of miles, orbiting different bodies in different regions of the solar system, producing the same chemical fingerprint that no known molecule can explain. Both worlds have nitrogen-methane atmospheres where ultraviolet sunlight drives organic chemistry similar to what may have preceded life on Earth, and both are producing at least one compound that no laboratory on our planet has ever cataloged. New Horizons gave us Pluto's face. Webb is giving us Pluto's chemistry. And between the two of them, the picture that is emerging is of a world far more complex, far more dynamic, and far more mysterious than anyone imagined when a spacecraft the size of a grand piano launched from Florida 20 years ago, on a trajectory toward a dot of light at the edge of the known solar system. And then, 3 weeks ago, the spacecraft woke up. On August 7, 2025, New Horizons entered its longest hibernation period ever. Its systems powered down to conserve energy, its instruments silent, its position deep in the Kuiper Belt far beyond Pluto. Mission controllers at the Johns Hopkins Applied Physics Laboratory stored wake-up commands on the spacecraft's main computer and waited. Nearly a year of silence. Nearly a year of a machine drifting alone through a region of space so empty that the nearest known object in any direction was millions of miles away. On June 23, 2026, those commands fired. The spacecraft came back online. On July 7th, NASA confirmed that New Horizons was in good health and ready to begin transmitting a stream of science data gathered during hibernation from its location in the Kuiper Belt. At that moment, New Horizons was 5.9 billion miles from Earth. Its radio signals, traveling at the speed of light, took nearly 9 hours to reach mission control. 9 hours each way. An 18-hour round trip for a single exchange of information. And it was still working. Still collecting measurements of the heliosphere, the charged particle environment. the solar wind's interaction with interstellar space, and the faint ultraviolet glow of hydrogen atoms scattered across the galaxy. In February 2026, mission scientists reported that New Horizons had detected an unexpected bump in pickup ion temperature over a 5-year period, a measurement that is still unexplained. In April 2025, it produced the first Lyman alpha map of ultraviolet light from the Milky Way itself, an observation only possible from its unique vantage point billions of miles from the sun's glare. In May 2025, it took images of Uranus from a geometry that had not been available since Voyager 2 flew past in 1986, images that will help scientists interpret data on similar planets orbiting other stars. In October 2024, it had crossed 60 AU, 60 times the distance from the Earth to the Sun, meaning it was now twice as far from the Sun as Pluto was when New Horizons flew past it 11 years earlier. It is the most distant active spacecraft with a functioning camera, the most distant active scientific observatory of any kind. And it just woke up and told us it is ready for more. The spacecraft launched in January 2006. It was designed for a Pluto flyby, and if possible, 1 or 2 Kuiper Belt object encounters. It has now been operating for over 20 years. It has visited 2 worlds no spacecraft had ever seen before. It has taken the most distant photographs ever captured by a human-made instrument. It has produced a dataset from a single afternoon at Pluto that is still generating first-ever discoveries more than a decade later. And it is still out there, still moving at roughly 31,000 miles per hour, still sending back data from a part of the solar system where no other active spacecraft exists. Here is what I want you to take away from all of this. New Horizons had a few hours at Pluto, a few hours to photograph a world that takes 248 years to orbit the Sun, a world with glaciers and volcanoes and mountains and an atmosphere and floating icebergs and landslides and a chemical signature that does not match anything in any database. A world that was demoted from the planetary club and then turned out to be one of the most geologically and chemically active places in the outer solar system. The spacecraft took those photographs on a Tuesday afternoon in July 2015. Scientists are still finding things in them that nobody saw before. The landslides were there the whole time. The crescent scars, the debris fields, the displaced blocks of ice cascading down crater walls and spreading across the floors below. They were in the data on the day it was transmitted back to Earth, across 3 billion miles of space. They sat there for 11 years, in an archive, waiting for someone to look at the images from the right angle, with the right question in mind, using the right comparison to features found on other worlds. That is not a failure of science. That is the nature of exploration. Every dataset contains more than the generation that collects it can extract. Every photograph holds details that only become visible when someone arrives with a question that did not exist when the photograph was taken. The tools change. The questions change, the context changes, and suddenly something that was always there becomes visible for the first time. The discovery was not made 11 years ago and missed. It was made 11 years ago and found now, because now is when the right eyes and the right framework came together. And New Horizons is still looking. From 5.9 billion miles away, carrying the most distant active instruments in human history, it is still measuring the environment at the edge of our solar system. Still transmitting data that takes 9 hours to reach us, still extending a mission that was supposed to end years ago. It has outlived its primary mission by more than a decade. It has outlived the assumptions about what it could accomplish. It has outlived the attention span of a public that thought the Pluto story ended in 2015. The spacecraft that visited Pluto and Arrokoth and is now drifting through the Kuiper Belt has become something its designers may not have fully anticipated. It has become a long-duration observatory, a continuous presence in a region of space that no other instrument can reach, measuring things that no telescope on Earth or in Earth orbit can see. And the photographs it took in those few hours at Pluto are still, 11 years later, producing discoveries that reshape our understanding of what icy worlds can do. 1 spacecraft, 1 flyby, 11 years, and the photographs it took in a few hours on a Tuesday afternoon in July 2015 are still not finished telling us what they contain. The question is, what else is waiting in them that nobody has thought to look for yet? If this kind of content is what you come here for, subscribe right now and turn on notifications. Next time, we are going deeper into the Kuiper Belt, because what New Horizons is detecting out there right now is raising questions nobody expected. Drop a comment with what surprised you most. The landslides hiding for 11 years, Arrokoth's shape, or the fact that this spacecraft just woke up 5.9 billion miles away. And share this with someone who thinks the Pluto mission ended in 2015, because it clearly did not. Thanks for watching.